Okay, so in the last class we have discussed how to calculate the optimum number of rain gauges in a given area. So the optimum number of rain gauges is basically to determine, so what should be the optimum number of rain gauges to be erected in a given area so that you can get a reasonably better value in the mean annual depth of rainfall recorded over a particular place. So we have already discussed this problem, how to calculate the optimum number of rain gauges required. So it is given by this equation, that is CV divided by P whole square. So now based on this data, so here CV is a statistical parameter and P is the desired degree of percentage of error. So that is 10%. So the stations are given here. We have 5 number of stations and the normal annual rainfall values have been given. And you have to calculate the X bar, that is the mean of these rainfall amounts. So X bar is sigma X divided by N. So you'll get the value of X bar. Then you can find out the difference of X bar minus, so X minus X bar whole square. Then you can calculate the standard deviation. So by using this formula, so then finally you can get the coefficient of variation, that is standard deviation by the X bar value. So it works out to be 33.1%. So the desired degree of percentage of error is limited to 10%. So thereby you will get the optimum number of rain gauges required in that given area is around 11. But the existing number of rain gauges is 6, but that means you require additional number of rain gauges. You require additional 5 number of rain gauges to be erected in that particular installed in that particular area in order to have a stable frequency mean values of the rainfall at all these stations. So additional rain gauge stations to be established is N by N. Capital N is optimum number of rain gauges and small n is the existing number of rain gauges. So the additional number of rain gauges required is around 6 because the existing rain gauge is 5. So the additional 6 rain gauges have to be distributed in proportion to the area between the isoheads as shown in figure. Now these are the isoheads. So whatever the additional number of rain gauges that you have calculated, it has to be distributed in proportion to the area between the isoheads. Now we shall discuss how to distribute these additional number of rain gauges depending on the area. Now here, the area, so we have nearly 6 zones. So the total area has been created as zone 1, zone 2, zone 3, zone 4, zone 5, zone 6. Now the area in corresponding zones are given. The area in kilometers square will be given to you. That is, it is 410, 900, 2850, 1750, and 720, and 550. So all put together, the total area is 7,180 kilometers square. Now, what you have to do is, you have to distribute this additional number of 6 number of rain gauges in each of these zones, depending on the area. Now, the area will be given to you. So you have 6 zones and the total area is 7,180 kilometers square. Now you have to calculate the area as a decimal. Area as decimal means, so this 410 divided by 7,180. So it works out to be 0.06. Like that, 900 divided by the total area, it is 0.12, 0.40, 0.24, 0.39, and 0.08. So if you add all this, it should be equal to 1. So the next step is the area will be given to you. You have to calculate area in decimals. That is 0.06 like that. If you add all this, it will be 1. Now, n into area in decimal. So n is nothing but the optimum number of rain gauges that you have calculated. That is 11. So you have to multiply the area in decimal with the optimum number of rain gauges. So you will get these values. That is 66, 1.32, 4.4, 2.64, 1.1, and 0.88. Now, you can round it off these numbers to the nearest one. So whatever the n into area in decimals, it can be rounded off to the nearest number. Now you can see here it is 0.66, the nearest is 1. So it is 1.32, so less than 1.5, you can take it as 1. And this is 4.4, you can take it as 4. It is 2.64, you can take it as 3, 1.1, 1, and 0.88, 1. So if you add all this, it is equal to the optimum number of rain gauges, that is 11. Now, the rain gauges existing in, that is how many rain gauges we have? 5 rain gauges existing. So now let us distribute each rain gauge in zone 1, zone 2, zone 3, zone 4, zone 5. So here only 5 existing rain gauges you have. Now, additional rain gauges, how many numbers you have calculated? 6. Now it has to be distributed. Now it is 1 minus 1, it works out to be 0, and 1 minus 1, it is also 0. So 4 minus 1, 3, and 3 minus 1, 2, and 1 minus 0, 1. So this is 6. So like this, zone 3, you can see here, since the area is too large, you require 3 additional rain gauges. And also area zone 4, you can see the area is too big. It is 1750 kilometers square, hence you require 2 additional rain gauges. And also zone 5, you have only 1 rain gauge, correct? Existing is not there, so you have to provide 1 more rain gauge. So like this, depending on the area in proportion, you can distribute the additional number of rain gauges that has calculated. You have to distribute it in according to the area. So this type of problems you may have in the examination. Sometimes you will be required to calculate only the optimum number of rain gauges. If not asked, if the area is given, then you need to follow this procedure. First, depending on the zones, these are the areas, you take the decimal and multiply this decimal value by the optimum number of rain gauges. You will get some values. So round it off to the nearest number, then the existing number of rain gauges. So you can allocate each rain gauge in each zone. Then finally, you can take the difference and find out the additional number of rain gauges required in different zones. Now, in the given problem, it has also been asked to find the percentage error P in the estimation of average depth of rainfall with the existing network. So what is the percentage error in the estimation of average depth of rainfall with the existing network, that is with the existing 5 rain gauges. So it can be given by the formula P, that is the percentage error you have to calculate. P is equal to CV divided by root of n. So here putting n is equal to small n, capital N is equal to small n. So because we are calculating the percentage error with the existing network. So existing number of rain gauges is 5. So putting capital N is equal to n. So the existing percentage error with the existing rain gauge network is about 14.8%. That means the accuracy is around 85.2%. So in the problem, it has been asked see here, what is the percentage accuracy of the existing network in the estimation of average depth of rainfall over the basin. So the percentage of accuracy with the existing rain gauge network is 85.2. So now you have calculated how many additional rain gauges required, that is 6. So if you incorporate these 6 rain gauges depending on the area, maybe the percentage of accuracy may go up to 90%. So now presentation of rainfall. presentation of rainfall. So how we can present the rainfall data. So for various purposes, whether it may be design purposes or the planning stage, we require this rainfall data. So how we can present this data. So rainfall at a place can be described by its intensity and duration and also frequency, how often it occurs. So second one is the intensity of rainfall is the rate at which it is falling. That is, the intensity of rainfall will be generally expressed in either in millimeters per hour or centimeters per hour. And the duration of the rainfall is the time from which rain is falling with given intensity. So the duration may be 1 hour, 2 hour, 3 hour, or it may be even up to 6 hours or 7 hours. So especially in the monsoon period, you may have the rainfall right from morning to evening with the same intensity. There won't be very splashy rainfall or a intense rainfall. So the frequency is the number of times the rainfall is occurring or falling. So the presentation of rainfall data at a given place can be described by its intensity of rainfall and also the duration of rainfall and also the frequency of rainfall, how often it rains. Now, uh, so the presentation of rainfall data can be done by two ways. That is, one is the mass curve of rainfall. So from the mass curve of the rainfall, you can find out the depth of rainfall, the intensity of rainfall, as well as the duration of the rainfall. So now you can see here, mass curve, it is a plot of accumulated precipitation against time. So it is nothing but it is the accumulated or it is cumulative rainfall in a given place, that is P in centimeter versus time in minutes or it may be also in hours. Now here it's a plot of the cumulative rainfall versus time, and mass curve is always a rising curve. Mass curve is always a rising curve because of the cumulative values of rainfall. So mass curve will be always a rising curve, but in some portion of the mass curve, you may have a straight line. You may have a straight line in some portion of the mass curve, so which indicates that periods of no rainfall. So whenever the rainfall takes place, again the mass curve starts rising. Correct. Now, by the rainfall values can be presented, or rainfall data can be presented by means of this mass curve of rainfall, which is a plot of cumulative rainfall versus time, and it is always a rising curve. Now, at any point of time, that is any time interval, you can calculate the slope of the mass curve, So that is delta P by delta T. So it will give the depth of precipitation. So what is the depth of precipitation? Now, during certain time interval, what is the intensity of rainfall? That is I is equal to delta P by delta T. So thereby, if you have this mass curve, it is a plot of cumulative rainfall versus time. So from the mass curve, you can calculate the depth of rainfall in a particular time period, and also the time period. These vertical ordinates will give you the depth of rainfall at different time intervals of a day, and the slope of the mass curve. You can get the intensity of rainfall either in centimeters per hour or millimeters per hour. So it's a plot of accumulated precipitation against time plotted in chronological order. It gives information on duration and magnitude of storm. Magnitude is nothing but the intensity. The intensity at various time intervals in a storm is nothing but you can calculate between these two time intervals, you can calculate the slope of the mass curve, thereby you will get the intensity of rainfall. So this is one method by which you can present the rainfall data. So next is you have a graph that is known as a hyetograph. Hyetograph is a plot of rainfall intensity versus time. Now you can see here there is some overlap in the figure. Now you can see here the hyetograph. Hyetograph is basically a bar graph. So it is a bar graph like this. You have the bar graph. So hyetograph is a plot of rainfall intensity against time interval. Hyetograph can be derived from the mass curve of rainfall. To draw the hyetograph, a convenient time period is chosen and corresponding accumulated rainfall is noted from the mass curve of the rainfall. So from this hyetograph, the intensity for that period is computed and it is plotted against the time period to get the hyetograph. Now you can see here, these are the intensities of rainfall at various time intervals of the day. So basically mass curve is a plot of accumulated precipitation versus time, whereas the hyetograph is a plot of intensity of rainfall in centimeters per hour versus time. So thereby you can get the depth of rainfall. What is the depth of rainfall at different time intervals of the day? The area under the hyetograph represents the total rainfall received in that period. Now you can see here it is a bar graph. It is simply a bar graph, and whatever the area within this graph corresponds to the total rainfall that has received in that particular time interval. So it is useful in the estimation and design of storm for predicting extreme flood, and also it helps in land drainage and design of culverts. So these are the two methods by which you can present the rainfall data. The first one is the mass curve and the second one is the hyetograph. Now, so for hydrological analysis, any hydrological investigation or analysis, the rainfall is considered as a point rainfall. So we are going to consider it as a point rainfall. So similarly in the forces, we consider the forces as a point force in the analysis of the external forces acting on any member. So in the similar fashion, we can consider all the rainfall recorded at a particular place as point rainfall. Point rainfall, also known as the station rainfall, refers to the rainfall data of a particular storm. It can be in the form of daily, or weekly, monthly, or seasonal, or annual amounts of rainfall. So these are also represented graphically in the form of bar diagrams. So point rainfall, that means in a given place you have a rain gauge. The rainfall may occur over the entire area, but whatever the rainfall amounts, you are going to record it only through those instruments, that is rain gauge instrument. So we consider all the rainfall that takes place surrounding a rain gauge as a point rainfall. So it can be also represented in the form of bar diagram. So the data, so you can collect it on daily basis, on weekly basis, monthly basis, or seasonal basis, or annual basis. Now here we have an important concept in the module 1, that is moving average curve. Now, so why this moving average curve is very important? It is one of the most popular method of calculating long-term trend. So this method also used for seasonal fluctuation, cyclical fluctuation, or irregular fluctuation. So in this method, we can calculate the moving averages for certain years. So the basic idea behind this moving average curve is, now you can see here, for any frequency analysis of rainfall, we require lengthy data for a period of say 20 to 30 years. So we require a very lengthy data. Now, if you present all these rainfall data in those particular years, it will be a bar graph like this. It will be a bar graph. So here you cannot predict the cyclic trend for the last 20 or 30 years. So in order to overcome this drawback, so the moving curve average will be very helpful in predicting the cycling pattern. So this is nothing but, you have heard a term about moving average curve. So especially in some economics graph, they calculate the moving average curve for number of years. So similarly, if you have rainfall data for number of years, you can present it in the form of a bar graph. You can present it in the form of a bar graph. It will not show you any cyclic trend. So the time is running out. I request all of you to mark your attendance in the chat box. If not, you have done. So in order to predict a cyclic pattern, the moving average curve will be very helpful. So here, in the case of moving average curve, the concept is very simple. So the group averages are calculated. The group averages are calculated and the average value is marked at the mid of the group. So here you can consider the group averages in numbers as 3. Either you can consider 3 or maximum 5. Maximum 5. So if you consider these 3 years, so you can take the average of these 3 years, and the average value is marked in the center of the group, that is here it is marked. So now, or else you can calculate the group averages for 5 years, 1, 2, 3, 4, 5. So now let us take the values of these 5 years and we can calculate the average, and this average value is marked at the mid of the group. That is 1 plus 1, 2, 3, 4, 5. So 3. So here you are going to mark the group average. So similarly, you can consider the next 5, omitting the first one. Omitting the first one. Next, you can consider 1, 2, 3, 4, 5, and take this average, and again you mark the group average at the center. So similarly, next, you can consider from this point, that is 1, 2, 3, 4, 5, omitting the previous one. So like that, you can plot the group averages of all these groups. That is, either it is better to consider 5 values so that you can mark at the mid of this average at the mid of the group. So you will get these points, and if you join these points by a very smooth curve, that is 5 years moving mean curve trend line. So it will, you can predict some trend when the rainfall is too intense and when the rainfall is less in a particular year. By this curve, you can analyze or can predict the cyclic pattern of the rainfall data in a particular place. Because usually for any hydrologic analysis, we require more number of data, so that is more number of years data. So this is one of the method by we can calculate the cyclic trend. So that is the moving average curve. So that completes the module one. Module one. So I have created the Google Classroom for 6th semester B section. So I'll send the details. So I'll be giving one assignment on module one. So anyway, I will share that information to all of you. So do you have any doubts? So that completes the first module, and I think the soft copy of the notes will be shared to you, okay, to the group. So you have any questions? Anyone? Hello? Hello, anyone has having any questions to ask? Hello? Anyone can respond? I'll randomly call the names. Vilas, Mr. Vilas. Who is this Redmi? So if you write like this, your attendance will not be considered. Yaar is the Redmi? Who is this? How many times I should tell? So you have to log in with your name and USN number. Otherwise, this.
Okay, sir.
Yarado, who is that? How many times I should tell? Yarido, who is this?
Yes, sir.
Yar Hesrain Nimdo. I can't see your name and USN number. Who is this? How many
Sir,
times?
Junaid, sir.
Ah, how many times I should tell?
Okay, sir.
You come with the problem that my attendance has not come in the jam. So in the beginning itself, I told you not to log in with these names, Redmi and all. And Pranita A. Shetty, you are not written your USN number. Pranita Shetty,
Yes, sir.
why you are not written your USN number?
ಸರ್ ಅದು ಲಿಂಕ್ ಮೂಲಕ ಬಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೆಸರು ಮತ್ತು USN ಬರುತ್ತೆ ಸರ್. ಜಸ್ಟ್ ಕೋಡ್ ಕೊಟ್ಟಾಗ ಜಸ್ಟ್ ನೇಮ್ ಬರ್ತಿತ್ತು.
It is better.
rename
Okay. You are getting the attendance status ಎಲ್ಲ ಕರೆಕ್ಟ್ ಆಗಿ ಬರ್ತಾ ಇದೆಯಾ ಜಾಮ್ಸ್ ಇಂದ ನಿಮ್ಗೆ?
ಇಲ್ಲ ಸರ್, ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡಿದ್ರು ಕೂಡ ಅದೇ ಪೇರೆಂಟ್ಸ್ ಫೋನಿಗೆ ಮಾಡ್ಲಿಲ್ಲ ಅಂತ ಬರ್ತಿದೆ ಸರ್.
Okay, now anyway. So every class ಅಲ್ಲಿ ನೀವು ಲಾಗಿನ್ ಆಗ್ತಿದ್ದಂಗೆ ಬೇಕಿದ್ರೆ ಒಂದು ಸ್ಕ್ರೀನ್ ಶಾಟ್ ತಕ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ ಅವತ್ತಿಂದ.
ಓಕೆ ಸರ್, ಓಕೆ.
Okay. So any other questions you have? I'll be ending the session. So tomorrow I'll start the second module. So I have completed the first module. Okay. So you can leave the class now. I'll be ending the session.